An octopus the size of a basketball is currently navigating a tiny drain pipe the exact size of a coin. This isn't a trick of the light. It is a feat of extreme biological engineering. To understand how they do it, we have to look at the unique relationship between their anatomy and their skin. For a human, this move is impossible. Our bodies are defined by a rigid internal skeleton. Those hard bones provide structure, but they also act as a physical limit on where we can fit. Without that internal frame to lean on, you'd expect an animal to collapse into a heap. Yet the octopus swims, crawls, and hunts with precision. By operating without a traditional skeleton, the octopus can move through the environment in ways that animals with bones simply cannot replicate. This structural flexibility starts with the fact that an octopus has 0 bones. Its entire body consists of soft, flexible tissue. Without a rigid frame, an octopus can compress its organs and muscles, stretching and flattening its mass to slide into the narrowest rock crevices. However, there is one exception to this softness: the beak. Located centrally, this hard structure functions much like a parrot's beak. This beak represents the octopus's only fixed dimension. If a gap lets that rigid beak through, the rest of the animal squashes to follow. This allows startling comparisons: a 60-pound octopus funneling its entire mass through a 2-inch hole. As long as the beak fits, the octopus can occupy almost any container or crevice, essentially taking the shape of its surroundings. While their lack of bones allows for structural shifting, their skin manages a second transformation, a complete visual overhaul. They achieve this using specialized cells called chromatophores. These are essentially tiny, elastic sacs of pigment. You can visualize them as thousands of microscopic balloons filled with paint, embedded directly in the skin. Using its nervous system to pull these sacs open or let them shrink, the octopus changes its entire color pattern in less than a second. This allows them to use camouflage to hide from predators, mimicking the exact colors and rough textures of the coral reefs and sand around them. When an animal can change both its physical dimensions and its color, it becomes one of the most effective hidden hunters in the ocean. Let's see how much you've picked up about these sea ninjas. I'll ask a question, you shout out the answer. First, how many bones does an octopus have in its arms? 0. They are completely soft-bodied. Second, what is the only hard part that determines if an octopus can fit through a hole? The beak. And finally, what do we call the tiny color-changing sacs in their skin? Chromatophores. If you got those right, you're ready for the lab crew. Click that subscribe button to join us. You've officially mastered the basics of octopus biology. Just remember, octopuses have 0 bones, their beak is their only limit, and chromatophores handle the camouflage. Talk to a grown-up today. If humans didn't have bones to hold us up, what's the smallest space you think you could squeeze into? We've seen how an octopus changes its own shape, but how do we measure the distance around a shape? That's called perimeter. Tap here to find out how it works.